Welcome to my video on adding rational expressions with common denominators. In this video we are going to focus on adding rational expressions together. They will have common denominators as stated in the title, and then the goal with our rational expressions will be to simplify them as best as we could, just like we did in the simplifying rational expressions video and the multiplying and dividing rational expressions videos. So we're always going to be trying to simplify them if we can, just that this time we are going to be adding them together. So with that said, let's take a look at our first example and see what we can do. Let's say we have the rational expression 5x over 12y cubed plus the rational expression x plus 2y over 12y cubed. Now just like if we were adding fractions, we need to have a common denominator, and we currently have them, so we can add these like follows. Add the tops together, keep the bottoms the same. So when we add these two rational expressions together, the denominator is going to stay 12y to the third. But the numerator is going to become 5x plus x plus 2y. And then from there we can combine any like terms. So I have 6x plus 2y all over 12y to the third. And we have successfully added these rational expressions together. Now we need to try and simplify them. And to do that, we need to factor anything out of the top that we can, and then see if we can factor that same part out of the bottom. So if I'm looking at the numerator, 6x plus 2y, I know that I can factor out of both the 6 and the 2, a 2. So I'm going to rewrite this as 2 times 3x plus y all over 12y to the third. If I can simplify it, that means I can factor out a 2 from the denominator as well, which I can. So the denominator can become 2 times 6y to the third. I have the 2 times 3x plus y in the numerator, and now these 2's will cancel because they are used for multiplication. No addition or subtraction allowed. So our final answer that is simplified is 3x plus y all over 6y to the third. And if you're wondering, hey, I have a y on the top and a y on the bottom, why can't I cross those out? Or my 3's and my 6's, why can't I cross those out? And the reason is because of the addition sign up top. Since we are adding the y, it's not going to cancel out a factor on the bottom. Same thing with the 3 and the 6. We are adding to it. You can only cross out when you are multiplying with the factor. Alright, so there's our first example. Let's take a look at another one. This time, let's say we have 8x over 3 plus 3x over 3. Now you might be saying, hey, I can cancel out those 3's right away, and you aren't wrong, but it's not going to help us. So let's just do the addition since we already have our common denominators. The 3's on the bottom are going to stay there. 8x plus 3x is 11x. And, well, we're done. We can't factor anything out of the top and out of the bottom. We have added the rational expressions together, and we cannot simplify them. So that one is pretty straightforward. Not too bad. And alright, let's do one more, just so that we can say we've done 3 examples, and then we're going to call it a day on these. Alright, we have the rational expression 6x plus 5 over x squared minus 3, and we're adding to it the rational expression 3x minus 1 over x squared minus 3. Easiest part of this is knowing what our common denominator is going to be, which is x squared minus 3. And then we are going to add the numerators just like we've done. So that's 6x plus 5 plus 3x minus 1. We're going to combine some like terms. So 6x plus 3x is 9x. 5 plus a negative 1, or 5 minus 1, is 4, a positive 4. And that's going to go over x squared minus 3. And try as we might, there's nothing we can do to simplify this one either, so we are done with this problem. We have successfully added these rational expressions together. And that's going to be it for this video, because if you have common denominators already, there's really not much we have to worry about if we can't simplify it, and if we can, well, it's the same stuff we did with simplifying rational expressions from last week's videos. So, hopefully you found this helpful. Good luck with adding like or common denominator rational expressions.